Hello again. So now we're going to do the third video on exam questions for permutations and combinations. In this first question, we have 5 members that we need for a committee. There are 5 men and 3 women, and we need exactly 2 women in the committee that we're going to select. So, as it doesn't matter in which order we select the committee members, this is a combination. This is the equation for combinations here. And first of all, we're going to work out the total number of committees that are possible. There are 8 people, so that is 8, and we're choosing 5 from them. And that gives us 56 different ways to choose a committee of 5 from 8 people. But as we want exactly 2 women in the committee, we will have to choose 2 from the 3 available, which means we have to choose 3 men from the 5 available. And if you put the numbers into the equation, you end up with 30 different ways to choose a committee that have exactly 2 women in it. And the probability is that number divided by the total number of committees, so 30 over 56, which reduces down to 15 over 28. But next, if we have no more than 2 women, that means we could have 2 women and 3 men, 1 woman, which means we'd have 4 men, or 0 women, which means we'd have 5 men. For the first scenario here, where we have 2 women and 3 men, we've just worked that out, so we know the answer is 30. For the second scenario, we are choosing 1 woman from 3, we are choosing 4 men from 5, and when we times that out, we get 15. And for the final scenario, with no women and 5 men, you can work it out with the equation, but there's not really any point because you have 5 men and we need 5, so there's only one way you can choose them. So the total number of committees with no more than 2 women is 46, which is 30 plus 15 plus 1. So if we divide 46 by the total number of committees, we get the probability, which is 23 over 28. In the next example, we have the letters of the word teach written on 5 separate pieces of card. How many arrangements can you make with these 5 letters? Well, this is a permutation, and the number of arrangements is going to be 5 factorial, which is 120. Next, we're working out the probability that the letters spell the word cheat. Well, there's only one way that you can spell the word cheat. So that's 1 divided by the total number of arrangements, which is 1 over 120. If T is the first letter, we're going to put T at the front to fix that position, but there's 4 letters to choose from for the second position, 3 for the third position, and so on. So the number of words you can make where the first letter is T is going to be 24. And the probability is 24 over 120. If the letters C and H are together, we're going to treat C and H as one unit together, so we effectively only have 4 letters to organise. So there are 24 different arrangements. However, you can have HC or CH, so we have to times that by 2, giving us 48. So the probability is 48 over 120. And lastly, for this question, the first letter is T and CH are next to each other. So we're going to fix T in position at the start, but now we only have effectively 3 items to choose from. So there are only 3 choices for the second letter, 2 for the third, etc., which gives us 6 combinations, but we have to times by 2 because HC can be organised in 2 ways, and the probability is 12 over 120. And lastly, we have 4 men and 4 women, and they're going to be lined up for a photograph, but no man and no woman must be next to each other. So we could line them up like this or like this. And we will have 4 choices of men to choose from for the first man in the row, but only 3 men left to choose from for the second man in the row, and 2 for the third, etc. And for the women, we have the same. We have 4 women to choose from for the first woman, only 3 women left to choose from for the second woman, and so on. So this is the same as saying 4 factorial times 4 factorial. Now the total number of arrangements is 8 factorial, as we have 8 people. So the probability that no women and no men stand next to each other is equal to the total number of arrangements where the men and the women do not stand next to each other. And we've worked that out to be 4 factorial times by 4 factorial times by 2, because there are 2 different scenarios where that happens, divided by the total number of arrangements of 8 people, which is 8 factorial. So the answer is 1 over 35, which is 0.0286. So that's it for this video. As always, thanks ever so much for watching, and if you like and subscribe, just hit those buttons. I'd really appreciate it. See you on the next one.